Hello students, welcome back in this video session of pharmaceutical organic chemistry. Now in today's video session we will be discussing about the IUPAC rules for nomenclature of carboxylic acids and its derivatives. So let's get started. What are carboxylic acids? Carboxylic acids are the most important acids in the organic chemistry, and these acids are represented by the general formula as below. So there is a alkyl or aryl group and there is a carbonyl group connected to the OH. Okay, so it is COOH. So this is referred as the carboxylic acid. Okay, so this is carboxylic acid, and this group is very important in the organic chemistry. So there are several compounds in the organic chemistry where you find the carboxylic acid as a functionality, and this is the group which is having the highest priority in the nomenclature system. So for numbering, whenever you find the carboxylic acid group, whatever functionalities we have studied so far in the previous sessions for the IUPAC, so this is the group which will get the highest priority. So if you find in any structure there is a presence of carboxylic acid, so you have to give the lowest possible number while numbering the parent chain. Okay, and then you can select the longest possible chain as usual. So this is about the carboxylic acid. Now we will see how these carboxylic acids can be named. So we'll discuss the IUPAC rules for nomenclature of carboxylic acids. So the rule number 1 says you have to use the suffix as OIC. It is referred as the oic acid to designate it contains the carboxylic acid functionality. Okay, so here we should remember the suffix is oic acid. Rule number 2 says the carboxylic acid group must be located at the terminal position, and we can number then starting with the number 1 with the carbon of the carboxylic acid. Okay, so that is rule number 2. Then rule number 3, if functional group is connected to a cyclic structure. Okay, it is to a cyclic structure, by mistake A is typed here. So if the functional group is connected to a cyclic structure, then we have to use the suffix as carboxylic acid. Okay, we'll see some of the examples where you can understand this. Then rule number 4, if the carboxyl group is named as a substituent, then the term carboxy is used. Okay, so if you find this carboxy group is used as a substituent, then we will be using the word as carboxy. Then we find in the books still the older names are preferably used to the compounds having up to 5 carbon atoms. Okay, for example, we find the name formic acid rather than the methanoic acid. Okay, or acetic word is used rather than the ethanoic acid. Okay, so still these are commonly used, and we find in some of the books they are widely preferred for naming the structure of the compounds. Now with the rules what we have studied, let's nomenclate this particular structure. Okay, so what the rule says, we have to start the numbering to the carbon atom of the carboxylic acid. Okay, so this is the carbon of the carboxylic acid, so this will be 1, this will be 2, 3, 4, 5, 6. Okay, and there are 2 methyl groups connected to this particular carbon, so we can simplify this structure in this way. So it is C double bond O OH. Alright, then there is a CH2, then there is a CH2, CH2, and then CH, and to this CH we have 2 methyl groups which are attached. So the numbering will start with carbon 1, 2, 3, 4 and 5, and we have to select the longest possible chain giving the least possible number or the lowest possible number to the carboxylic acid carbon. Okay, so I can give this carbon, let's say as number 6. So this methyl will be considered as substituent. So what we have? We have substituent at carbon 5. So it will be 5-methyl, and it is a parent chain is a hexane. Okay, so it is hexane. So the E will go and oic acid will be added as a suffix. So we can write the name of this compound. So first we can write the substituent, only one substituent is present. So it will be 5-methyl, and then it is a hexane. Okay, so E will go and it will be written as oic acid. Okay, so this will be the correct name for the above mentioned structure, 5-methyl hexanoic acid. Oic acid will represent, it contains the carboxylic acid functionality in the structure. Alright, now can you try this structure? Now if you carefully observe this structure, you can easily make out there are 2 carboxylic acid groups. One is here and one more is here. So let's say if I am starting the numbering from this carbon, so this will be 1, it will be 2, 3, 4, and there is one more carbon. So this is the longest possible chain containing the carboxylic acid functionality having least possible number. You can also number this structure in this direction also, from left to right the number will remain same. Okay, both carboxylic acid functionality are present at carbon 1 and 5. So here the 2 carboxylic acid functionalities are present. Okay, so how we can name? We can write the locants or the primary prefix. So at carbon 1 and 5 we have the carboxylic acid, and it is a pentane. Okay, so E will go and it will be oic acid, but you should remember there are 2 carboxylic acid functionalities. So whenever we have 2 carboxylic acid or the 2 functionalities, we use a word or prefix as a di. So here also we can use that, and we can write it is a pentane. So here E will not go because we are using this di. We already encountered such kind of problems in the earlier functionalities. It is a pentane doic acid. Okay, so for this structure the correct name will be 1,5 pentane doic acid. This is commonly referred as, so this is a structure of glutaric acid. Okay, you might have come across this substance. It is a glutaric acid structure, and by IUPAC system we can name it as 1,5 pentane doic acid. Okay, now let's see one more example. Now here you can easily make out there are 2 functionalities. One is this keto and other one is this carboxylic acid. Now I told you, among whatever functionalities we have studied so far in the previous video session, carboxylic acid will get the highest priority. So you have to give the numbering in such a way that the carboxylic acid carbon will get the lowest possible number. So obviously if you are going in this direction for numbering, obviously it will not get the lowest possible number. You have to go in this direction. Okay, so let's say this will be 1, 2, 3, 4, 5, 6, and we can also extend to this carbon because this is the lowest, sorry, this is the longest parent chain, and then this methyl and this methyl can be considered as substituent. Okay, so what we have 2 methyl substituent, and there is one more functionality at carbon 3. So this is the keto functionality. When it is present as substituent, if you remember the earlier videos, it is represented as oxo. Okay, so how we can write the name of this compound? Can you try? You can pause the video and you can comment your answer in the chat box. So we have to write the substituent first. So at carbon 6 we find 2 substituents. So it will be 6, 6. Then di prefix will be used for indicating 2 methyl groups. So it will be dimethyl, D should be capital, dimethyl. Then at carbon 3 we have the oxo, so oxo will come, and then the parent chain is containing 7 carbon atoms, so it is a heptane, and E will go and oic acid will be used as a suffix to indicate the carboxylic acid functionality. Alright, so how we can write? Without space you can write it is a heptanoic acid. Okay, so hope you got this answer. 6,6-dimethyl 3-oxo-heptanoic acid. Okay, now we'll see one more structure. So again here you can make out there are 2 functionalities. One is here, that is double bond, that is alkene. Then there is one more functionality here, substituent is present as the amino. Okay, we have discussed already the IUPAC naming for amines, and then our major functionality, that is the carboxylic acid. So obviously the numbering will start with this carbon, this will be 2, this will be 3, 4, 5, 6, there is one more carbon here, and 7. So again it is a heptane, and there is a amino functionality at carbon 3, and at 5 and 6 there is a double bond, so it is a alkene. So whenever you have alkene we use a suffix as E and E. Okay, so amino will take a priority while writing the name, so you can indicate at what locant it is at carbon 3, and A should be capital, so it will be 3-amino. Okay, can you guess what will be the next? Obviously we have to indicate the presence of double bond, so it will be starting at carbon 5, so it will be 5-, and it is a heptane. Okay, so because of the double bond it will be heptene. We have studied the IUPAC of alkenes, so I request, if you have not watched all the previous videos, you have to watch those first, and then it will be easy to understand these carboxylic acid compounds nomenclature and its derivatives. Okay, so it will be 5, then it will be heptene, E and E. Okay, and then what will come? Heptanoic acid. Okay, so this E will go, and the place of E will be taken by the OIC acid. Okay, oic acid, because for carboxylic acid we have the suffix oic acid. Okay, and we have used here, instead of A of heptane, this we have replaced with E to indicate it is a double bond. Okay, so the correct name for this compound will be 3-amino-5-heptanoic acid, not heptanoic acid. It is a heptanoic acid. Okay, now in some of the structures you can find the carboxylic acid is present as a substituent on the cyclic structure. Okay, so this is a cyclic structure. So what the rule we have seen, whenever carboxylic acid is present as a substituent on the cyclic structure, we have to use the suffix as carboxylic acid. Okay, so here we can write the name of this compound, it is a benzene. We can give the space and we can write it as a carboxylic acid. Okay, you should know what is the name of this compound. It is a benzoic acid. It is very important acid in the pharmaceuticals as well as in organic chemistry. The common name of this structure is a benzoic acid. It has the acid functionality, carboxylic acid, and the IUPAC name will be benzene carboxylic acid. Okay, alright. Now you find in books still the older cysteine is used to designate the position of the substituents. Okay, in the carboxylic acid, so they use the Greek letters rather than the numbering as 1, 2, 3. Okay, so here you can see, if I want to give the IUPAC name for this compound, we can easily give the numbering for these carbons as 1 to 6. So it is a hexanoic acid, and at carbon 3 we have a chlorine atom. So in Greek terminologies, the carbon atom of the carboxylic acid. So what is the next carbon? So this is the next carbon. So this will be referred as alpha. Then next carbon to the alpha will be referred as beta, then gamma, delta, and so on. Okay, so in such case I can also write the name of this substituent as beta chloro hexanoic acid. Okay, so in some of the books for reference you may find this kind of nomenclature. Okay, beta chlorohexanoic acid. So this beta indicates the position of the substituent. So how you have to give the letters here, Greek letters? You have to see the next carbon to the carboxylic acid carbon. So next carbon, immediate carbon will get as alpha, the next will be beta, and so on. So with that, can you name this structure? It is a 2-bromopentanoic acid. Okay, so this is a carboxylic acid carbon. So this carbon will be alpha, this will be beta, and so on. Okay, so there are no substituents here, so we are not supposed to write that. So how we can write here? It will be alpha bromopentanoic acid. Alpha bromopentanoic acid will be the name for this structure, using the Greek letters for locating the substituents. Okay, all right. So if you understood all these rules with the explanation by taking some of the suitable structures, I think you should be able to write the correct name for this structure. Okay, so you can see the carboxylic acid functionality is here. Then you can easily make out there is a substituent here, and this is a cyclohexane. Okay, so this is also referred as a substituent here. So whenever you have the cyclic structure which are saturated, we refer it as a cyclohexyl, and so on. Okay, so you can find out the parent chain. So carboxylic acid carbon will get number 1, then this will be 2, this will be 3, 4, and this will be 5. So it is a pentanoic acid, and then substituent at carbon 2 and at carbon 3. Okay, so what are the substituents here? One is the cyclohexyl. Okay, don't write cyclohexane. Whenever this cyclic structure are present as substituent, this suffix is used for the substituent. It will be cyclohexyl, and the other one is a methyl. Okay, so these are the two substituents. So obviously who will get priority in writing the name? Obviously you have to write it in a alphabetical order. Okay, so cyclohexyl will get a priority because it has letter C. So it will be 3-cyclohexyl dash 2 dash, it is methyl, and then without space you can write it is a pentanoic acid. Okay, it is a pentanoic acid. So this is the correct name for this structure. Got it? Okay, now let's go ahead. Now here the name is given and you are supposed to draw the structure from the IUPAC name. So it is 3-cyclohexene. Okay, so you can, what you can do, you can first see what are the different parts of the structure. So there is a cyclohexene. It is not cyclohexane or cyclohexyl. It is cyclohexene. ENE indicates there is a presence of double bond in the structure, and it is here it is mentioned as only carbon 3. That means only there is a one double bond. Okay, if it would have been diene, trine, then there will be a multiple double bond. Then it is 1,2 dicarboxylic acid. That means the carboxylic acid functionality is there, and there are 2 carboxylic acid functionality at carbon 1 and carbon 2. So we can rearrange this structure as per the nomenclature. Okay, so let's say I have indicated a double bond here. So double bond will not get a priority while numbering. Who will get priority? Obviously the carboxylic acid will get a priority. So we have to give the least possible number. Okay, so now you can see whether we have drawn the correct structure for this name. So let's say if I am numbering from this carbon of the one which is attached to the carboxylic acid, so this will be 1, this will be 2, this will be 3, and so on. Okay, so this will be the correct name for this structure, 3-cyclohexene 1,2 dicarboxylic acid. Okay, all right. Next, 3 amino. Okay, so amino means there is a NH2, 6 dibromo, then it means there are 2 bromine atoms. Okay, and 2 methyl decanoic acid. Decane means how many carbon atoms? There are 10 carbon atoms, and there is also a methyl group. Okay, so these are the substituents. So we can draw the skeleton of carbon containing 10 carbon atoms. Okay, so 1 2 3 4 5 6 7 8 9, and let's say I am drawing one more here. So give the numbering 1 2 3 4 5 6 7 8 9 and 10. Okay, so let's say if this is a carboxylic acid, because we have given number 1 to this carbon, so this will be a carboxylic acid. Then at carbon 2 what we have a methyl, and at carbon 6 we have a dibromo, so we can attach 2 bromine atoms here, and at carbon 3 we have a amino group, so there will be a amino. Okay, so we have attached this amino, bromine is attached, methyl is attached, so it is a decanoic acid. So 10 carbons are also there. Now we have to complete the valency of the carbon, so it will be CH2, this will be CH2, CH2, this is already completed, CH2, CH2, this will be CH, and this will be CH. Okay, so this is the correct structure for 3 amino 6 dibromo 2 methyl decanoic acid. Alright, okay. Now we have discussed the IUPAC system for the nomenclature of carboxylic acids. Now we can also have the possibility of derivatives of the carboxylic acid. So what are carboxylic acid derivatives? Okay, carboxylic acid derivatives. So these are the compounds in which hydroxy group of carboxylic acid is replaced by another heteroatom or the group. Okay, so this is the general formula we have used to represent the carboxylic acid, RCOOH. So this R, it could be a alkyl or it could be a aryl, and there is a C double bond O, and the same carbon is attached to the OH, that is hydroxy group. So when you replace this hydroxy group with either heteroatom or a particular group, we refer them as the carboxylic acid derivatives, because they are prepared from this one. Okay, so carboxylic acid are converted to its carboxylic acid derivatives by suitable chemical reaction. Okay, so how we can replace? Now you can see here the hydroxyl group is replaced with the X. X is nothing but the halogen atom. Okay, like iodine, bromine, chlorine, and so on. So when this OH is replaced by the halogen atom, we refer them as the derivative of carboxylic acid, and to be specific, it is referred as the acyl halide. Okay, then if you are replacing this OH with this one OC double bond O, like that, then it is considered as the carboxylic anhydride. Okay, then when this OH is replaced with the OR, okay, so it will become COC or any alkyl group, okay, or aryl group, so it will become a ester. Okay, so ester is a derivative of carboxylic acid. Then here you can see it is the amino group. Okay, so this is referred as the amide because there is a C double bond O. So when C double bond O and NH will come, it will be referred as amide. So acyl halide, carboxylic anhydride ester, and amide, these are the prominent and very important derivatives of carboxylic acid, and all these are very important in organic chemistry as well as the pharmaceutical or medicinal chemistry. So we should be able to know how we can name these compounds. Okay, so we'll start one by one. First we will see the acyl halides. So what we have seen, what are acyl halides? Acyl halides are the compounds in which the hydroxyl group is replaced by the halogen atom. Okay, so it could be iodine, it could be fluorine, chlorine, or bromine. Okay, and in such case, whenever you see the acyl halide structure, you have to use the suffix as oil, and you have to find out the parent name. Okay, so parent name followed by a separate word to designate the specific halogen atom. Okay, so commonly we have seen with the common acids, okay, we have used the halogen as having a suffix as YL. Okay, so let's say I am drawing the structure here of CH3 CH2 Cl. So in this case, this is a parent chain, it is a ethyl. Okay, so YL is used and then we write as ethyl chloride. But when you find the acids are not normal acid, it is a carboxylic acid, and the OH group is replaced by the chlorine. So in this case, we have to use this suffix as OYL, oil. So with that, you can see in this X is the chlorine. Okay, so the parent chain is this one, 1 and 2. So we have to count the carbon of the carboxylic acid or the carbonyl group. So it will be ethanoil. Okay, it is a ethane. E will be dropped and OYL will be suffixed. So it is a ethanoil chloride. That is the correct IUPAC for this structure, and it is very commonly referred as the acetyl chloride. Okay, so acetyl chloride is again an important compound in the organic chemistry. Similarly, you can see again there is a chlorine, then this will be 1, 2 and 3. So it is a propane. So E will be dropped of propane and OYL will be attached. So it will be a propanoyl chloride, and this is a common name, that is propionoyl chloride. Similarly, you can see here there is a benzene ring, and to this carbonyl carbon the chlorine halogen atom is attached. So it will be benzoyl instead of benzene. Okay, E is dropped and OYL is attached, so it will be a benzoyl chloride. This is again an important reagent in many organic reactions. Okay, so this is the examples of acyl halides. Now next is the carboxylic anhydride. So this is again an derivative of the carboxylic acid. So carboxylic anhydride are named from the appropriate carboxylic acid. With the substituent additional word, we have to use it as anhydride. Okay, so you can see here, to this carbon, this is the OH or hydroxy group of your carboxylic acid, and this has this particular group OC double bond O dash. So this we refer it as anhydride. So this is carboxylic anhydride. So when similar groups are connected to the common oxygen atom, which is common oxygen atom, this is the common oxygen atom. So when you find there are similar groups which are attached to this common oxygen, then the acid name is used without the prefix di. So you need not to indicate the word as di. Okay, but when two different groups are connected to the common oxygen atom, their carboxylic acid names are used as a separate words. So we will understand this in a better way by taking the suitable example, these two rules for the carboxylic acid derivatives. Now what the rule says, so this is the general formula for carboxylic acid anhydride, and this is the common oxygen. Okay, so when similar groups are connected to the common oxygen atom, the acid name is used without the prefix di. So here in this structure you can see this is one group and this is the another group, and they are similar and they are attached to the common oxygen. So this is the common oxygen. So in this case you need not to use the di word for these two substituents or the two groups. So what name you can give it here? In this case this will be 1 and this will be 2, again this will be 1 and this will be 2. So can you guess what will be the name here? So it is methane and ethane. Okay, so it is again a carboxylic. Okay, so it will be a ethanoic. Okay, it will be a ethanoic. So you can write the name as ethanoic, and then what we have to do, there is no need to use a prefix di because both are similar, which are connected to a common oxygen, and then we have to use the suffix as anhydride. Okay, so just simply attach the suffix here as ethanoic anhydride. Okay, can you tell me the name of this structure, common name? It is CH3COOH. What is CH3COOH? It is acetic acid. So here it is acetic anhydride. The common name of this compound is acetic anhydride, and ethanoic anhydride is the correct IUPAC name for this structure. Now let's try the another compound here. Again this will be 1, 2 and 3, and on the other side also it is 1, 2 and 3. So two similar groups are attached to the common oxygen atom. So again we need not to use a prefix as a di, so it is a propanoic. Okay, you can use the word here, it is a propanoic, and you can use a suffix as anhydride to indicate it is a carboxylic anhydride. Okay, so it is a propanoic anhydride. That is the correct name for this particular structure. So this rule you have to remember when you find two similar groups are attached to the common oxygen atom. Then there is a possibility that to the common oxygen atom two different groups can be attached. Okay, so in such case how you can give the nomenclature? So what you have to do, when you find two different groups are connected to a common oxygen atom, carboxylic acid names are used as a separate words. Okay, so here you can see this is a one type of group and this is the another type of group. Okay, so if you are giving a numbering here, this will be 1, this will be 1, 2 and 3. Okay, this carbon is 2 and this will be 3. So how you can give the name for this? So on one side we have a cyclopropane and the other side we have the propanoic acid. So when you see the alphabetical order, obviously this has a letter of P and this has a letter of C. So cyclo will come first and you can write cyclopropane, and this is referred as a carboxylic acid, right? So it is a cyclopropane, carboxylic, and then the other substituent, it is a propanoic. So it is a propanoic, and then you can add the suffix anhydride. Okay, all these three words are written separately with the space. So the correct name for this structure will be cyclopropane carboxylic propanoic anhydride. Okay, so can you name this structure accordingly? Okay, just try. So this will be 1, 2, 3, 4 and 5. So it is a pentanoic. 1, 2 and 3, it is a propanoic. Okay, so one is pentane and other one is a propane. So which one you will write first? Obviously you have to see the alphabetical order. So after P, here also there is a P, here also there is a P, then go for the next letter, it is E, and here it is R. So obviously this will be prioritized while writing the name of this compound. Okay, so how you can write? It is a pentanoic, then it is a propanoic, and then it is a anhydride. It is a anhydride. So that is the correct name for this particular structure. Okay, all right. Now the next class of derivatives of carboxylic acid is the carboxylic acid ester. Okay, so here you can see the general formula for carboxylic acid ester. Here the OH group is replaced by the OR. So these are named by using a combination of the name of alcohol and carboxylic acid component of the molecule. The alcohol root name is used with an YL as a ending as if it were a substituent, but it is written as an initial separate word. The second word is the parent name for the carboxylic acid with the suffix OAT, that is OAT, replacing the oic acid of the carboxylic acid. So when ester group is named as a substituent, you can write it as alkoxycarbonyl, or you can write it as carboalkoxy. Okay. And when you find there are salts of this carboxylic acid, so they have a similar nomenclature in which the cations are named first and then the remaining part. Okay. So we'll see how these rules can be implemented for these esters. So here you can see this is an example of carboxylic acid ester. So in such case, how we can give the name of this compound? So here you can see it is 1 and 2, so that is it is ethyl. Okay, so YL will come for the alcoholic functionality. So here you know the OH is replaced here with the OR. Okay, so this part is nothing but your OR. So in that case we are adding the suffix as YL, and the remaining part is your this cyclohexane. Okay, so here we can write the name of this structure as ethyl will come first, so it will be ethyl, then cyclohexane, and then it is a carboxylate. That ATE will come as a suffix to indicate it is a carboxylic acid ester. Okay, so it is cyclohexane carboxylate. Okay, so this is how you can give the name for this structure. Okay, let's try this one. This is a salt. Okay, so there is a cation sodium, so that will be referred first. So you can write it is a sodium, and then this is a benzene ring and COO minus, so it is a benzoate. ATE will be a suffix, then this OATE will be a suffix, and this benzene E will be dropped and ATE will be added as the ending letter. So the correct name for this structure will be sodium benzoate. So here we have to remember, when we find such type of salts, so these cations will be named first while naming these compounds. Now you can see in this structure, so here you can easily make out there is a benzene ring and one of the hydrogen is replaced with this particular group. So in such case, if you remember the earlier rules, instead of benzene or benzyl, we have to use a letter phenyl, and then this remaining part will be a ethanoate. Okay, ethanoate. So this is the correct name for this structure, phenyl ethanoate. This can also be commonly referred as phenyl acetate. Okay, acetate group is there, so you can also refer it as phenyl acetate. The IUPAC name is phenyl ethanoate. Okay, now can you try this structure? So there is a cyclohexane and this particular functionality here. So here cyclohexyl will take a lead, so it will be a cyclohexyl, and then it is methane and propane. So it is with a space you can write it is a propanoate. OATE will be a suffix, and it is a propane. E will be dropped and OATE will be added as the suffix. So correct name for this structure will be cyclohexyl propanoate. Okay, now next class of carboxylic acid derivatives is amides. Okay, so here you can see this NH functionality will be added here to this carbonyl carbon of carboxylic acid. Okay, so this is referred as amide. So in case of these compounds, while nomenclature we have to use the suffix as amide. So amide is used with the parent name to designate it is an amide. For example, here again the numbering will begin with the carbon of the carbonyl group or the amidic carbon, and this will be 2. Okay, so it is methane, ethane. So ethane, E will be dropped and amide will be added. Okay, so how it will be written as ethane. Okay, so E will be dropped and amide will be added. So it is ethanamide. Ethanamide is the correct IUPAC name for this structure, and it is commonly referred as the acetamide. Okay, acetamide is again popularly used in the pharmaceutical chemistry. So we'll see how we can give the nomenclature for the functionalities having this amide functionality. Okay, so there are two functionalities, one is amide and there is a alkene here. Okay, carbon carbon double bond. So amide functionality will get a priority. So this will be number 1, 2, 3 and 4. So it is a butane. Okay, and at carbon 2 the double bond is starting. So can you write the name of this compound? You can locate the position of the double bond. As such, there are no substituents here, so it will be a 2. Then whether it is a butane or butene, it will be a butene, alright, because of the double bond. So it will be a butene. Okay, E will be dropped, and then what we have to add suffix? It will be added as amide as a suffix. Okay, so E is dropped of butene and it will be amide. So simply you can write it is a 2-butenamide. That is the correct name for this structure. Okay, now can you solve this and comment your answer in the chat box? So this will be number 1, 2 and 3, and there is a substituent on this nitrogen. Okay, so this is actually ethyl. Okay, this is CH2 and CH3, CH2 CH3. So there are 2 ethyl substituent on this nitrogen. So in such case, we have seen in the amides how we can write it is N, N, then di we can use di, then it is ethyl, and then it is a propane, so it will be a propanamide. Okay, it is a propane, it does not have any double bond like last structure, so it is a propane. E will be dropped and amide will be attached. So the correct name for this structure will be N-diethyl propanamide. Okay, all right. Then whenever we talk about the carboxylic acids and the derivatives of the carboxylic acid, we often consider, along with these carboxylic acid derivatives, we also consider the nitriles. Okay, because they can be interchangeably used. Okay, and you can easily synthesize these, okay, from one of these derivatives. So these nitriles are represented by this generalized formula. It is C triply bonded to this nitrogen. Okay, so their nomenclature reflect a relation of these nitriles to the carboxylic acid, and in such case, whenever you find a nitrile functionality, we use a suffix or the ending word as a nitrile or O-nitrile, and this is added to the parent name. Numbering include the nitrile carbon atom. Okay, so it is similar to that of the carboxylic acids and its derivatives, where we have considered the carbon of the carboxylic acid and its derivative. So here also we have to consider this carbon which is attached to the nitrogen of this nitrile. And then we can also use a prefix as cyano, okay, when nitrile group is present as the substituent. So we will see some of the examples. So this is a carbon, so I can start the numbering here. A halogen atom will have a least priority, so this will be 2, this will be 3 and this will be 4. Okay, so here the nitrile is not present as a substituent, it is a part of the parent chain. Okay, so we cannot write here as a cyano, so we have to write the substituent as 3-chloro. Okay, and it is a butane, so it will be a, what you can write here, chloro, it is a butane, right? butane nitrile. 3-chloro-butane nitrile will be the correct name for this compound. Okay. Can you try this structure? There are 2 nitrile groups here. Can give the numbering 1, 2, 3, 4, 5, 6. Okay. So you can use a prefix as a di. So it is a hexane. So predict the answer for this structure. Put your answer in the chat box. What will be the answer here? It will be hexane dinitrile. Hexane dinitrile will be the correct name. Okay, you can also indicate the location of the nitrile group, but even if you mention it like this, even then it is alright. Now, how you can draw the structure from the IUPAC name? For example, here 3-cyano-butanoic acid. 3-cyano-butanoic acid. So it is a butane. That means you can draw the 4-carbon skeleton. Then at carbon 3 we have a cyano. Okay, so nitrile is present here as a substituent, so you can attach at carbon 3 as a cyano. So where you can attach the other functionality, it is oic acid. That means definitely there is a carboxylic acid. So whether you will attach a carboxylic acid to this carbon or to this carbon. Okay, can you guess? Now if you attach here, then this will be 2 cyano, right? Because the carboxylic acid will get a highest priority and you have to give the lowest possible number to this functionality. So this will be COOH on the left side. So this will get number 1, this will be 2, this will be 3, and this will be 4. Okay, 3-cyano-butanoic acid, nothing else. So you can attach the hydrogen atoms to complete the valency of this carbon. So this will be H and this will be CH2. Okay, so this is how you can write the structure, 3-cyano-butanoic acid. So for your exercise, you can try to draw the structure of this compound, propene nitride. You should remember here it is E and E, that indicates there is a double bond, and it is a nitrile. That means the carbon triply bonded to the nitrogen is present as a part of the parent chain. It is not present as the substituent. Okay, so you can try to answer this. I think you will be able to draw the structure correctly. So I hope you have understood all these rules. You can practice with some more structures. So here we have completed the IUPAC nomenclature system for your organic compounds. In the next lecture we will start the structural isomerism in the organic compounds. Thank you for watching this video.